What is so? Chapter is laws of motion. Laws of motion. We're already in chapter 5.
Law of inertia.
Laws of motion. Okay. What is the first law? Newton's first law.
An object in rest will continue in rest, and an object in uniform motion will be in uniform motion until and unless any external force is applied.
Okay. So a body which will be at rest will stay in its place of rest as long as someone doesn't come and disturbs it. Or if it is in a motion, what motion? Uniform motion. It will keep going like that forever until unless someone come and give it a push or a pull, right? Or slow it down. So that is called the. So how this thing started? It started with, first these observations were started with Aristotle. So,
yes, sir. Yes.
Aristotle. First thing we have to, or else if we don't take this Aristotelian. So it is the Aristotelian who first introduced this. Now he is a Greek, but if I tell you his era was around 384 to 329 BC. Okay, what did he say? That everybody moves and motions tend to slow down and comes to rest. So he said that everybody, and now we look at it, what he is saying. He said that natural state of a body is at rest. Natural state of a body is rest. Okay. Then he also said an external force is required. An external force is required. Force is required to maintain its motion, to maintain a motion of a body. To maintain a motion of a body. Simple. This was Aristotelian fallacy. Now, if I tell you, even before Aristotle, even before Galileo, even before Newton, it was in India. I'll show you. You should know it and you should write it. Is the just a minute, I'll show you. His name is here. I think, where was that? Yeah, here is it. Read this article. What is the name?
Brahmagupta.
Brahmagupta, na? He found out gravity long time back. This was gravity. I'll come to that later. Oh, they disturb so much, na? It was gravity, and then before that, where was it? Here you might find it. I'm forgetting that name for a reason, because those Sanskrit names I forget. You will find it here. Where was it? Malabar. Yeah, here is somewhere. No. What was his name? Panini.
Panini was for grammar.
No. Panini, and then here Kannad. Yeah, it was Kannad. Okay, you see, read this. The Kannad's Vaisheshika Sutra. Rishi Kannad. This is Rishi Kannad. What is he saying? Rishi Kannad Vaisheshika Sutra says what? That the change of motion is due to impressed force. Correct? What is second law? The change of motion is proportional to the Newton said, and here you can read in Hindi, or this is Vaima Nimitta Vishwapad Karmanno Jayate, means same thing. It is saying the same thing, exactly the same way he is saying. So when is this? It is 2nd century BC, 6th or 2nd century before Christ. 6th It is 600 before 600 years before Christ. Understand? So long back, and this is in 16th century AD. Got it? 1600, after 1600 years from Christ, Newton is saying. So this is really, and you can see who was also quoted. This is how the gravity was stolen. He cannot be wrong, no? Subramanian Swami cannot be wrong. So that was the questions. That was this thing in very near future. This thing will be corrected. So we will also include here our own Saint Kannad, who was the first fellow who introduced it. So it was 600 years before Christ. Before Christ. Can you understand? This is also, this date is even challenging. It is even further. So that is Newton's first law. So Newton first, then comes, before next comes the Galileo. Now we have two. So this is the first. Then you can see Greek and Indians were Greeks used to, they are the travelers. They have visited India long time, many times, and we Indians used to spread our knowledge, and from there they have got it. So we are rediscovering everything now. That's the same thing. That's the thing. Now next is the two. That is the Aristotelian fallacy. Then finally we'll come to Galileo. How this everything started. It starts with Galileo's experiment. So what is Galileo's experiment? If you remember, do you remember Galileo's experiment?
So that he dropped the object from certain heights and observed.
Yes, Galileo's experiment is that you take a U shape like this. He made two things. If you drop a ball from here, it is going to fall and it is going to rise to what? Same height, right? If the floor is smooth, no other friction is present, it will what? It will go on forever and ever, right? It will never stop. He also proved that if you take a floor like this, it falls from here, and if it is being carried out in vacuum or in space where nothing, he said that later though, it was found out later though, that if this ball is not under any kind of repulsive force, what will happen? What will happen? It will again go on forever. Okay? So he said speed increases. He also said that speed increases as the ball comes down. Now if you take the ball up, now you see this is, if you take a ball and put it, it is going up an inclined plane, speed decreases. Okay, this was what Galileo's observations was, and this was his experiment with two inclined planes. This was his experiments. So based, after that comes Newton. Okay, so Newton said that, Newton gave the first law. So first law of Newton says that what? Every body which is at rest will remain stay in the rest until unless it is being disturbed by some other external force, or a body which is in uniform motion will continue to do so until and unless some external forces acts against it. So that is the Newton's first law of motion. Am I right? We all know it.
Yes.
This law is also called the law of what? Law of inertia. So I am not writing this sentence here, as you already know. That is Newton's first law. Now let us come to inertia. What is inertia? What is inertia? May I clean the board now?
The tendency of a body to...
May I clean it?
Yes.
So what is inertia?
So the tendency of a body to remain rest or uniform motion.
Okay, it is a inherent property of a body. It is a inherent property, or a property of a body, by virtue of which it resists it resist any change. Resist any change in its what? State of rest
Rest or uniform.
or uniform motion. Uniform motion. Now, inertia we can classify it into two types. We can classify it into three particularly. What are they? Inertia,
Rest, inertia of motion.
inertia of rest. So as the name suggests, a person's example, a person standing in a bus, what will happen? Falls what? Which side? Forward or backward?
So backward.
Backward. When? Backward.
So when the bus starts from west.
When the bus suddenly starts from what? Rest. So this is the inertia of rest. Directly giving the example. Okay, so tendency of a body to remain in rest is called what? Inertia of a rest. Number 2. Inertia. So any other example you want to give?
So
Inertia
from
of
this
rest.
only we can understand.
Hmm?
So from this only we can understand.
No, you give me example. You give me example. Inertia of rest. Some other example.
So when a cloth tied to when a cloth is hanged and beaten up, the dust falls down.
Very good. That is called the carpet. When you want to clean dust from a carpet, what do? You beat the carpet, right? So that is inertia of rest. Now inertia of motion. What will happen? A tendency of body to remain at rest. Remain in motion. Remain in what kind of motion? Accelerated motion? Accelerated motion or what? State of uniform motion. Uniform motion is called what? Inertia of motion. Example? What example can you give? Suddenly when the car applies the brake, when a car applies brake, what happened?
So person falls forward.
A person falls forward. That's it. Finally, it is inertia of direction. What is that? Inertia of direction. Can you tell what is inertia of direction?
So when the direction is changed, the original body tends in its original direction.
When a body takes a sharp turn, find an example for me. A person sitting in the car experiences a force acting away from the center of gravity. From the center, not gravity, whatever, the center of car path. This is the direction. I am giving you the direct example of this one. You try to move away. So inertia of direction would be that inability of body to change its direction. This inability of body to change its direction during a motion is called inertia. Another example I will give you. Have you seen, this is a wheel which is rolling on a muddy surface. You will see the mud goes out tangentially like this.
Yes.
Yes.
This is an example of what? This is a very good example of inertia of direction. Okay, let's come to so how do you measure inertia? How do you measure inertia? Measuring inertia, I'll give you an example. This is a 1000 ton, 1000 kg stone, and this is a 10 kg stone. Which one will be easy to roll?
Sir, 10 kg.
How can you say?
It's less than weight.
Because of what? Because of the mass, no? So mass,
Yes, sir. G
mass
will be
is
same,
the
so
measure
force will
of
be less.
mass is the measure of inertia. Okay? Greater mass means what? More inertia. Right?
Yes, sir.
May I clean it?
Yes.
Next come to the linear momentum. What is linear momentum? Linear momentum is what? This is divided by p, it's a vector quantity. It is defined as the product of mass and velocity of the
Sir,
object.
linear momentum is also a vector.
Yeah, it's a vector quantity.
Oh yes, sir, velocity.
Linear momentum is a vector quantity. So it is velocity vector is multiplied by scalar m. Okay? So linear momentum is a, so to understand linear momentum, you can just write is a product of mass and velocity. But what is linear momentum actually? How will you understand linear momentum? What is come? You can see, you can indirectly write that p is directly proportional to velocity for an object. So if I take two objects, two small spherical balls, one velocity is 100 meter per second and another one is 10 meter per second, definitely whose momentum is more?
So the first one.
First
100 meter
one.
one.
That means both of them being 1 kg less than 1 kg. So I can see this, it is 100. What is the SI unit? What is the SI unit? Tell me. Kg meter per second. Come on, Abhishek. Then dimension. What is the dimension?
Sir, M.
M1 L1 t to the power minus 1.
Yeah, fast. So this is the dimension. So 100 what? 100 kg meter per second. And this one is 10 kg meter per second. So if you are playing a cricket, okay, and if someone hits a ball, you will see some ball, when you hit a ball very slowly or lightly, you will see it will go to a glass window pane and get bounce and come back. But when that is hitted, when you hit that with a very large or massive force, we will talk about that massive force. You will see what will happen. It will break the window and it will pass through it. But when it breaks the window, you will notice that the window pane has only been made a hole and the ball has went through it. Am I right?
So can you repeat?
You see, if you hit the ball very hard, very hard, okay, you will see it will go through the window glass, just creating a small hole here. I'll show you. Maybe we'll get a video. I've used the word here. Do you see this?
Yes.
Yes, sir.
Do you see this? Look at this picture. Look at this picture. What happened here? What happened here? it is going through the, without the glass hasn't broken, but a hole has been created, but the whole glass did not break, though it has got shattered. But you can see there will be few more. If a bullet is fired, you will see the bullet will go through the glass. I'll show you.
Yes.
Bullet, instead of cricket ball, bullet. Okay, you have to explain me this. You see, look at this case. Can you see this picture? You see?
Yes.
You see this picture? It is passing through, right? Look at this picture. So what is happening here? Why the whole glass is not breaking? Can you explain me this?
So because the inertia of the glass is higher.
The momentum of the bullet is extremely large. Momentum of the is extremely large. The windshield or the glass is at rest. Its inertia of rest is also quite large. So when it goes, correct, momentum is too fast for that, and as a result, what will happen? It is going to create only hole, only the one where it is under the contact. Again, the glass will get elongated, extended, and then it will break. Understand? But not for the whole of the glass, only the region through where the bullet is going through. So here is the scene, right? These are different example of that one. So now that's fine. So this is an example of what? Momentum, and as well as linear momentum, as well as what? Inertia. Correct? The glass is at inertia of what? Rest, and the bullet has a very large momentum, and it do not want to change its state of motion, so it is in inertia of motion is there. Also its momentum is very large, so you'll see very soon conservation of momentum is also coming. So momentum is actually what? Product of mass into velocity. It is a vector quantity, and like that. Now we will see we'll do some analysis now. So variation of momentum, let's see. First case, if I consider two objects, this is M1, this is M2. Let's say these two bodies, M1 is greater than M2. So if I compare them, both are going with the same velocity v. Whose momentum is large? P1 by P2. If I do, I will see that M1 v by M2 v, I see that P1 by P2 is equal to M1 by M2. This showing me what? P is directly proportional to mass. Means the graph is a straight line. Graph is a straight line. So if I take a graph between P and M, the slope should give me what? Tan theta should give me P by M, which is what? Velocity. Example, if I give you an object like this, definitely what kind of motion is this? It is a uniform motion, right?
Yes, yes.
So in this case v is constant. So you can see if I give you a graph like this way, I give you this point, I give you this 2 point here. So this one is maybe 2, this is 3, this is 2, this is 4. Can you find the velocity? How will you find the velocity? So simple. So tan theta would be equal to 4 minus 2, no, so 3 minus 2 by 4 minus 2. That gives me the velocity. So 3 minus 2 by 4 minus 2 is how much? It will give me 1 by 2 or 0.5. So velocity is 0.5 meter per second. Simple. May I clear it?
Yes.
So we have done this one. The second case, okay, let it be here. We will be needing it. Number 2. Now, let's say, so next, So we have changed the mass. What about the velocity? Same mass. Now I consider two objects of same mass, but the velocity is being different. V1 and V2. Which one do you think will have larger momentum? Is P1 greater or P2 greater?
The one with the higher velocity.
So it is from how can we say that? Both being same mass. Imagine we have a two car here. One car is which one will cause more damage? Let's see. 1000 kg, both of them, both of the car or the vehicle is 1000 kg. Now 1000 kg, this one is moving at a speed of 50 km per hour, and this one is going at 20 km per hour. Which one do you create more damage? 50 or the first one or the second one? Definitely the first one. First one. So P1 by P2 will be written as what? V1 by V2. Again we can conclude P is directly proportional to V. The same the car will be again if I go by P and V, I will see the graph is again, so mass is being what? Constant. Okay. Second. Number 4, third one. What about in this case, why don't we vary the when two objects, their momentum is same. Okay, when their momentum is same, so if I say two objects, this is m1 moving with the velocity v1, this is m2 moving with the velocity v2, both of their momentum being same, then what is it? That means m1 v1 is equal to m2 v2, right? m1 v1 is equal to m2 v2. Then what can we write? So you can see that implies m1 by m2 is equal to v2 by v1. Now this is m1 by m2. m1 by m2, you can see clearly implies m is directly proportional to 1 by v. Now this is a rational function. Any function which is in this form, y equal to 1 by x, is called a rational function. Or I can write like this: f of x is called 1 by x, is called a rational function. For any rational function, the graph is like this. So this is just the most basic rational function. So its graph is actually like this. This is called the vertical asymptote. This is called the horizontal asymptote. Okay, so the graph will be like this way. This two is going towards infinity. This line is coming towards is horizontal asymptote, and this line is going towards is vertical asymptote. In between they are not connected. Okay, so in this case, so that means this is what? If this is x, this is minus x. So this is v, this is minus v. So you can see mass and mass cannot be negative. Mass cannot be negative. Am I right?
Yes, sir.
Yes, sir.
Mass cannot be negative. So here we are checking. So that means we are not going to include this. We are not going to include this. Okay. So we are only going to look into the variation will be only this one. So the graph between them will be like this. Okay. The graph between them will be that is between m and v will be this. Whether you by v by m, take v by m because m cannot be negative. So we are neglecting minus m is not possible. But yes, v by m is possible. V by v can be negative. V can be negative. Then although mass cannot be negative, then the graph will be something else. So better it is. This is wrong. This is sorry. This is right. This is mathematically wrong. Okay. This is right. This is right because if you take here, v can be negative. I can take v minus a here, but m cannot be negative. So this is not possible. This is possible. So that can be a tricky question for you. So whether the graph is m versus v or v versus m. Okay. So this is it. Understand? So that is the variation of all of them. Clear? So what do you see from here? If m is more, velocity will be, if m is more, velocity will be what?
Less.
Less. And if v is m is less, definitely velocity will be more. Okay? Keeping the same momentum. Keeping the same momentum. Correct? May I clean it?
Yes, sir.
So if I give you one question that a 100 kg car, no, 1000 kg car and 1000 kg, okay, 1000 kg car and a 10,000 and a 5000 kg car has same momentum. Has same momentum. Whose velocity, which is moving with a larger velocity? Whose velocity is more?
So the 1000 kg.
Or I can say like this, or in this way. Which one has a greater kinetic energy? Which one has greater kinetic energy? Which one? Which one? 100 kg or 5000 kg? Take another question. Mass of electron is 9.1 into 10 to the power minus 31 kg. Mass of a proton is 1.27 into 10 to the power minus 27 kg approximately. If both of them has same momentum, if both the particle has same velocity, same momentum, which particle has greater kinetic energy? Has greater kinetic energy. How will you do it? I'll give you an example. We know kinetic energy is given as, from your junior classes, you know, half m v square. So this is the relation between P and kinetic energy. Okay? So what we can do here, I can multiply it and divide by m. So m square v square. I'm going to write Ke as E. So this one will give me P square by 2m. So P is equal to 2me root. Very, very important relation. So can you tell which one will have greater kinetic energy if their momentum being same? Again you see, E and m, they vary how? P square by 2 being constant. Again it's a rational function. M cannot be negative. So again the graph will be what? Like this. Okay? Okay?
Yes, sir.
So which one do you think will have greater kinetic energy?
Sir, in which question?
Second
So
question.
then first one, it should be.
Which one do you think?
In the first one, it should be the second car, and in the second one, it should be.
I think in the first one it should be 1000 kg car, and in the second one it should be mass of proton.
What is your answer, Abhishek?
So in the first one, it should be second car, and in the second one, it should be mass of proton.
Proton will have larger one, or
10 to the power.
which one is smaller, Me or MP? In the first case, the answer is 1000 kg because mass decreases, energy increases.
Yes, sir. They are inversely proportional.
Inversely proportional. That's why I'm giving you the graph, na. This is M, this is E. Look, as M decreases, E increases. Okay? What about the second one? Is 10 to the minus 31 kg greater or 10 to the minus 27 kg greater? Remember,
So 10 to the power minus 27 kg is greater.
more you come close, negative comes to a 0. More far you go,
Yes.
this will keep increasing. this negative will keep increasing. Okay, so is this small? So right side is small, left side is, sorry, yeah, in this side it would be like this way. Okay, you understand this way. So that means, so this is smaller. So electron and proton, which one will have greater kinetic energy? Definitely electron will have greater kinetic energy. Is it or not? So I can ask another question also, that both of them I give a velocity of this much. If both the particle has same momentum, so instead of giving same momentum, I can give you a velocity. That I give a velocity of 2 into 10 to the power 4 meter per second to both of them. Now you tell me which one has greater kinetic energy. You calculate and tell me. Calculate and tell me what is the which one has greater. Which one do you think has greater? Because both of them has been given what? Same velocity of 2 into 10 to the power 4 meter per second. Right? So P will be how much?
Mass of electron, so that electron will have greater kinetic energy because its mass is more.
Yeah. So whether I give by my one word answer this one word, one sentence answer, that's it. That electron will be have larger momentum compared to what?
Proton.
Yes. Done?
Yes.
Yes, sir.
May I clean it?
Yes, sir.
Yes.
Now let us come to, so all other things you have learned, these are very basic rudimentary thing. Now let us come to Newton's second law. What is Newton's second law?
So force is directly proportional to
No. That definition you have to clean it. Forget it. You have to forget that. Newton's second law of motion says that, you see, if this is any vehicle which is moving on a straight road, okay, what do you think? Which one provides the external force? Does the engine provide the external force or some other agencies provide the external force? Which one provides the external force? Which one? Marnav?
The engine.
No.
So engine,
No. Very soon you will learn engine provides,
the wind.
engine is the internal forces. It do not provide the external forces. Because if you keep the neutral in, if you keep on a neutral, car will not move.
Yes.
When you are keeping on a first gear, the external forces apply by the friction between the wheel and the surface.
Yes.
And greater you accelerate, greater that they will start rotating, the wheels will start to rotate and it will start pushing forward. That means the Newton's second law of motion states that the rate of change of momentum, you have to use this, rate of change of momentum is directly proportional to rate of change of momentum of what? Rate of change of momentum of any body is directly proportional to what? To the applied external force. So first thing says what? First thing says the body will be at rest. Now when you are coming in motion, you must be applying a force. So more force I give, more will be the momentum. That means P is directly proportional to dP by dt. Now you must know what is dP by dt. I have taught you this, that dP by dt is nothing but it's a slope of a curve. Okay, dP by dt is nothing but slope of a tangent at any particular point. Remember it. Remember that one properly. Okay, so that means we will see that during numericals. So F is equals to then K d by dt into mass into mv, which you can write this K being any constant, because proportional sign whenever being removed we have to bring some constant. Now K d m dv by dt, what is this? Dv by dt is nothing but the acceleration. So that means force is equal to k mass into acceleration. Now in standard cases, k is considered to be 1. Okay,
Yes.
k is equal to 1, so we take this as F is equal to mass into acceleration. Again, this is our force. Oh my god, and this is so important one. Without this, nothing can be done. Okay,
Yes.
Newton second. So what is the, now how do you define force now? So that is, what is SI unit of force?
Newton.
Newton. SI unit of force is 1 Newton. Okay, how will you say? 1 Newton is equals to 1 kg
1 kg,
into 1 meter
1 meter.
per second square. That means when a unit mass, okay, when a 1 kg mass achieves an acceleration of how much? 1 meter per second square, then the force acting on that, external force acting on the body is how much? 1 Newton. What is the CGS unit? CGS unit of force is what?
9.
Dyne. So 1 dyne is equals to how much? I have taught you. 1 Newton is equals to how much dyne? 10 to the power
10
5
to the
dyne.
power 5.
10 to the power 5 dyne. Okay. Then other forces also there. Now this is very important. This is required in case of practical. Kg weight. I don't know whether you have done or not. It is called kg weight. So 1 kg weight, which we can also write like this, kg f. Can you guess what is it? Kg weight. Kg weight. You see, we know force is equals to mass into acceleration. So if I take this g,
Yes.
m into 9.8, okay,
Yes.
so that means how much is this? So this is 1 kg weight, and km equals to 1 kg, then 1 kg weight will be equals to 1 kg weight will be equals to 9.8 Newton. That means you are referring from what? Weight of the object. Okay.
Yes.
Similarly, 1 gram weight. 1 gram weight would be same thing. It is just 980 dyne. Okay. And these are different. Clear? Make it?
Yes, sir.
Understand? So this is
Yes.
now Newton's second law. Where is it? Yeah. So one thing you should conclude: acceleration will only be caused by what?
Force.
Acceleration will know what kind of force will only
External force.
be achieved in a body, achieved by a body only. The acceleration will only be achieved by a body. Acceleration will only be achieved by a body under the effect of external force. This is also second law in a different way. Okay. Clear?
Yes. Sir.
May clean it?
So that means every type of acceleration has its own force.
If you
Yes. Right. Of course.
definitely has its own, don't just say force. Net external force. Net. Now what is net? We will see to that. May clean it?
Yes. Sir.
Now, why don't you try this? A bullet of mass 0.04 kg is fired with a velocity is fired with a velocity of 0.04 meter per second. No, what I'm saying, 90 meter per second. 90 meter per second. Enters a wooden block. Enters a wooden block and enters a wooden block and it, what is the sentence, what is that called? It is penetrate. You need penetrate 60 centimeter deep into it. Okay, give the resistive force. Give the resistive force. Now you see resistive, it should come, F should come negative. Give the resistive force imparted by the block on the bullet. Should I give you a few minutes to do? Will you be able to do? Can you visualize this problem? Can you visualize this problem? This is the wooden block. Common situation. Here is the this is the bullet which fires. It penetrates up to 60 centimeter and then penetrates 60 centimeter and then it stops. So what is the resistive force? How much? Done?
So the time is not given.
No. We don't need time. You need to find the retardation. Just use v square equals to u square minus 2s. U is how much? 0.0, no, 90.
90.
0 equals to implies 0 equals to 90 square minus 2 into a into distance is 60, 0.6. Solve it from here, tell me. So 90 square is equals to, it is minus 2, 5. And then that will give me 2, 5, 0.12. 0.12 a into 0.12, 0.12 and then 90 square 81. So acceleration is coming minus 81 into 10 to the power 2 divided by 0.12. How much? It will be large, 100. So 12 na 12 6 2 is 12, so 72, 12, 6. 6,
Sir, it is almost equal to 7.6 into 10 to the power
6750.
minus 7.
Minus 6750, I think. 6750 meter per second square. This is it. So that means force will be mass into acceleration. Mass is how much? 0.04 into 6750. So 100 cancel. So 4 times of 600. 4 times of 6 was 2400. And 4 times of 70 is how much? 7 was 28. 24 and 28. So 2600. And 4 times of 500, 200. So that gives me 270. And then 270. 270 Newton minus. Okay.
Sir, but here when the wooden block would apply the resistance force, then its mass should also be taken.
Yeah, I have taken the bullet mass. Why will take the block mass? We will take. When to take, we will see. I will do one problem in later. You will see. I will be doing this problem here. I have a block. A block came, and then the block bullet came. It penetrates into it, and then it also rises to a certain height. We will do that. How much height does it rise? What is this angular theta? How much is this theta? If this length, I will tell you. We will do that. Okay? What is this energy? And now we'll do that in later. May clean it? No, don't. We will need this. Don't worry. We will need this. I'm giving you a very real life situation. You must have seen that during school time. Okay? Sometimes the children get very late while going to school, right? So their parents literally drag the kid by holding their both the hands, clear, to take to school. Now I'm giving a question on that. A child got late. A child got late. Child gets late to, please excuse my sentence, to go to school. So his parents is rushing with the kid to take him to reach the school assembly. Very common situation, right?
Yes.
If the parents give a force of 5 Newton each on the two hands of the No, 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 no. Don't give like that. Mm, okay. Don't give force. Okay. If the parents impart, the parents, no, no, no. If parents are walking at the speed of 2 meter per second and 3 meter per second, okay, per second, having masses of 60 kg and 70 kg respectively, what is the velocity of the child if its mass is 40 kg and his hands are held at 120 degree by their parents. Do you understand the situation?
Sir, didn't
Yes,
get
so,
you.
but parent speed is very fast, sir. 2 meter per second and 3 meter per second.
Yeah, you can imagine the situation. That means the father is holding the one hand and the mother is holding the another hand, okay, and they are literally dragging because they are late for the school, okay, and they are quite far from each other. The hands are making an angle of how much? 120 degree. It's an exaggerated one, okay, it may not be 120 degree, let's say approximately 120 degree. So what is the velocity of the, I'll give you necessary data. How will you do it? How will you do it? Can you imagine the situation like this?
Yes, sir.
Yes, sir.
So draw two vectors, P being a momentum vectors. This is P1, this is P2, this is 120 degree. Here is the kid. This is the resultant momentum of the kid, right? So P1 would be how much? mv. This one will be mv, right? So tell now. Will you be able to do? I leave this for you to do. Okay?
Yes, sir.
That's it for today. Okay? And please are you doing that?
Yes, sir. Started.
Okay. That one which I given you, please solve that and do this also. We will see next class. Okay then.
Yes.